All right, what I want to do now is show you how to draw a tripeptide. And one thing before we get started, just note I added this mention here that the double bond prevents rotation here at the peptide bond from the previous video. But what we're going to do here is I'm just going to kind of walk you through a sort of way that we can draw any dipeptide, tripeptide, tetrapeptide, something like that, so we can understand the overall structure of that. So what we're going to do is start with step one, and that is to draw those backbone atoms for as many residues as is needed. So since this is a tripeptide, we're going to go through the backbone atoms N, C alpha, C double bond O 3 times. So I'm going to draw that. I'm going to do this in line angle notation. So I'll start with drawing the N and then C alpha. I'm not going to label it alpha, but that is the alpha carbon. And then C double bond O. I'll go again N and then C alpha and then C double bond O. Notice I'm kind of doing this zigzag up and down, back and forth like that. So that is now 2 units, N C alpha, C double bond O, N C alpha, C double bond O. And then I'll do it again. So we got N, C alpha, C double bond O. So this is a tripeptide, and so it's going to have 3 individual units. So here's one amino acid unit, here's another amino acid unit in the middle, and then on the right is yet another one, right? So notice that's going to give us 2 peptide bonds, right? 3 things are joined together by 2 linkages. So here's one peptide bond, this amide, and then this amide, this peptide bond right there. So a couple other things that kind of gets us step 1, but step 2 is to add the appropriate side chains. And so again, you don't have to memorize what the side chains are, but you would be given a structure list and you'd have to recognize that S would be serine and A would be alanine and G would be glycine, for example. So I would look them up somewhere and I would discover that serine side chain has a group like this with a carbon, and then it has that hydroxyl group or OH group like this. Next, I would look for alanine on my list, and alanine has just a methyl group, so I could put it like that. If you wanted to just remind yourself, you could put a CH3 on there like that, but I'm going to leave it just kind of blank with that methyl endpoint like that. And then glycine is the amino acid that doesn't really have much of a side chain. It just has 2 hydrogens. So if you really wanted to, just to be clear, you could draw in 2 hydrogens at that alpha carbon there. But I'm going to leave them off just because I want to keep it in sort of proper line angle notation form. So that's step 2. Those are the appropriate side chains. And then step 3 is to satisfy the octets and also protonation states. So remember this, and I will typically give you instructions to make sure you were at the right pH. So this is going to be pH 7, and that means that the functional groups need to reflect that, and all octets have to be satisfied. So first up, I'm just going to start on the left and work my way right. So I've got a free amine here. This is not an amide, right? There's no carbonyl right next door to it. So this is an amine, and it's going to then need to have some protons on it. In fact, at pH 7, of course, it's going to need 3 protons because it's going to be fully protonated with its higher pKa around 8 to 10, and so it's going to be positively charged. I am not going to mess around with the serine side chain. That's a hydroxyl. It should stay that way. And then we get to the amide functional group, the peptide bond right here, and this nitrogen is currently only making 2 bonds. So to satisfy its octet, it's going to need a hydrogen, okay? And you can draw it that way. Another way that I sometimes draw the hydrogen for the peptide bond is to put it off like this. I kind of like doing that way as well, because this kind of highlights that it's a bond. And I'm going to do that on both of them. So I'll put the other one up here like that. So now both nitrogens of the peptide bonds have full and satisfied octets. One thing I'll point out is that, amides are always neutral. So never remove or add protons to them beyond that, right? So just amides are always neutral. So don't add or remove protons beyond what we've just done there. That has to be just neutral. And working our way again to the right, nothing needs to happen to the side chain of alanine, and then the glycine side chain just being hydrogens is fine. But this right here is missing something, right? The C terminus of the peptide, polypeptide, must have another oxygen. So that's a carboxylate group, and at pH 7, it's going to carry a negative charge like that. So the only charges in this example are from the N terminus and the C terminus. And of course, that's going to have an overall neutral charge because the side chains are not ionizable. Glycine, alanine, and serine do not ever take on charges regardless of what the pH is. So just to be clear, I'll label the side chains. So this is the serine side chain, this is the alanine side chain, and this is the glycine side chain. And just to be clear that this one is going to be deprotonated at pH 7, and then this one will be protonated at pH 7. And now we have a complete and satisfied structure of this SAG tripeptide as it would appear at pH 7.